Hello everybody and welcome back to Elementary Statistics Online at Frederick Community College. In this video, I will talk about standard deviation and variance, what these terms mean in the study of statistics, and how to use various tools to compute standard deviation. So I will use Excel, which is not required for this class, but I think it's a great idea to see how computations can be done very quickly. And then we'll also use TI-83 or 84 calculator to confirm our results. So let's take a look at the following example. Let's say I have a set of data over here, and these numbers represent number of text messages sent per month by a group of high school students. So I have 16 students that said, okay, here are my numbers. This is how many text messages I send per month. Okay, one way to characterize this set is to find the mean, and you know what that is? That is just the sum of all the values divided by the number of observations. Okay, so you could find all the sum by hand, divide by 16, or using a calculator command or Excel command. We're going to say average, open parentheses, highlight our data set, press enter, and there you have it. So roughly 327 text messages. That's the average for this set. Okay, now what if I would like to see how this data set is spread out, meaning how to, on average, how do my values in this column differ from the mean? Okay, so let's take a look at the first student. So this student sent 423 messages. Okay, so his or her observation is higher than the mean, right, by a little bit under 100. So let's see, if I were to do 423 minus this value right here, I get 96.3. Okay, so this value is higher by 96, roughly 96 text messages. Okay, and let's go ahead and do these computations for all of them. All right, so I have some students who sent fewer than the average number of text messages, and this student sent more, less, and so forth. Okay, so that's what these numbers represent. So positive means above the mean, negative means below the mean. Okay, so what if I wanted to now take a look at the average of the difference? Okay, on average, how do my values differ from the mean? So that's what this x minus mean means. Okay, so these are all differences of all observations in the set from the mean. And if I were to find the average of these differences, what would I do? I would have to add them all up again and divide by 16 in this case, right? That is my sample size. Well, let's go ahead and add it up and see what happens. If I were to add up all of these numbers, oh no, bummer, we get a 0. So let's think about, what does that mean? Does that mean the average difference of all my observations from the mean is 0? Is this telling me that my values don't differ on average from the mean? That doesn't really make sense, right? Because they do. They all differ, okay? It's just some of them are higher, others are lower than the mean. But no matter which set you pick, this value will always be 0. And you can check. Just pick a random set of data sets, find the mean, find x minus the mean, add them up. You will always get a 0. So this is not a good way for us to measure the average distance of the values in the set from the mean. Okay, and it's a fairly simple exercise to show this in general without actual values, but in a more abstract way, so that this value will always be 0. So we still want to measure how this set is spread. What we're going to do now, we're going to square each of the observations. Okay, each of the observations in this column right here. So observation minus the mean, we're going to square them to eliminate those negative signs. Okay, so you can say, here's my value, and I'm going to square it. Okay, and now I'm going to do that for all of them. Okay, now once you square your observations from that column, what's going to happen? You're going to eliminate all the negatives, right? So all of your values will be positive. Okay, let's go ahead and sum them up now. We're going to get a relatively large number, but that's okay. So we'll get this number right here. And now, remember what we're trying to do. We're trying to find the average, right? The average of the difference between the values and the mean. Okay, so if I were to do what? If I were to do the following. So I sum them all up, and now I'm going to take this value and divide by the number of observations in my set. So 16. So that's going to actually give me variance. Okay, and then standard deviation. And let's say this is, if we consider this set as a population, will be the square root of the variance, this number right here. Okay, so we get 98.759. You might be asking me, why are we taking the square root? Remember, we took that square over here, right? We took the square. We squared all of our values. So now to undo it, because we still want to find the distance, right? We are taking the square root of the found average. Okay, so that is your standard deviation if we consider this set as population, and it measures how your values in the set differ from the mean on average. Okay, so in this case, it's roughly 99 text messages if this set is considered as population. Okay, now if this set is considered to be a sample, so let's do sample. Okay, what is the difference? If you remember the formula, the difference was that we divide by n minus 1. This summation right here is divided by n minus 1. So I'm going to do, well, let me see. Let me find that summation divided by 15 first. So I would do my sum over here, divide by 16 minus 1, that's 15. Okay, so now I will be taking the square root of this value right here. So if it's a sample, our standard deviation will be just a little bit higher. So that's how you would do it by hand, so to speak, by actually doing all the steps, not really by hand, but without actual commands. So now you've seen how the computations are done. Let's see if we have the same results by using Excel commands. Okay, so standard deviation, I'm going to just type it in like this, STDEV, and now look, it gives me all these options. If I look at my set as population dot P, and I'm highlighting the original set, look at that, same thing, exactly. Okay, and then let's do the same thing here, standard deviation, if this is a sample, not population, then we get the following data. Okay, and look, they match exactly to as many decimals as you would like. Okay, and Excel is really nice because you can set as many decimals as you would like, and you're gonna get really nice, beautiful numbers. So this method right here that I did below the table, that's really how things work under the hood, right? Over here, what Excel is doing is everything what I've done, but it's kind of doing it in the back, right? So without showing you all of the computations. Okay, so how would you do it on your calculator? Let's see. I already have all my data points in my calculator. So let's go in here. I can just turn on. And if you go to Stat, Edit, and you see that my values are already in column 1. Okay, you can plug it in any column you would like. So what I'm going to do now is the following. Stat, Calc, 1 variable statistics, L1, enter. And let's see, do I get the same values? Absolutely. Here's my mean. Okay. Here my standard deviations. S of x, that is the standard deviation if this set is considered to be a sample. And look, it's exactly the same thing. Sigma of x is 98.76, which matches these values exactly. So in practice, in this class, you guys would never do these computations by hand. It's good to know where these numbers come from, but in practice, when it comes to computations, solving problems, you would just plug this all in your calculator, use 1 variable statistics command, boom, you got your numbers. So now that you know how to compute this in a couple of different ways, let's actually talk about what this measures. And I'm going to take a look at a couple of different distributions. So here, the first set, I'm looking at symmetric bell-shaped distribution that we're going to talk about a lot in this class. And you see that I have one distribution of the data here on the left, and then a similar shape, but a lot more spread out, right? It's not as tall, this distribution, but it's a lot more spread out. So your standard deviation here will be higher. You see how this piece right here, that represents the standard deviation of my second set, is longer. It's bigger than this standard deviation of the set on the left. So I don't really know what these values are. It doesn't matter. But the point here is I can take a look at my data and say, oh, okay, the population on the right is a lot more spread out than the one on the left. So whatever the values are, I know sigma 1 is smaller than sigma 2, okay? And this type of distribution is very special. We'll talk about it a lot. This is called normal distribution or symmetric, bell-shaped, also Gaussian distribution. That's another terminology that's used to describe this particular distribution. So you can see now what the actual representation of standard deviation is. It is the distance. It is the distance of the average distance, how the values in the set differ from the mean, okay? And then, of course, we can compute it for any type of distribution. So here, I'll just give you a couple of examples. We can have a bimodal distribution where we have 2 spikes over here, spikes, right? So I have some mean, some standard deviation. I don't know what these values are for this particular problem. It doesn't really have any parameters defined, but we can always compute it, okay? And over here, I have a distribution that's left skewed, so I have a high concentration of the data on the right and a tail on the left, and we're going to talk about properties of mean and standard deviation for this type of distribution, but they can all be computed, okay? So standard deviation for each of these distribution can also be computed, okay? So variance then, in this class, all you need to do is to know that variance is the square of the standard deviation. And in this class, we won't really discuss variance too much. In high-level statistics, there's a lot more time dedicated to analysis of variance. For us, the important part is that variance is just the square of the standard deviation, or standard deviation is the square root of the variance. But again, if you look at your calculator, you don't get variance over here, you get the standard deviation, okay? And that is the characteristic that we will need to use a lot, in particular once we start talking about inferential statistics, so hypothesis testing, confidence intervals, and so forth, okay? So the important part that I want you to get out of this video is how to compute the standard deviation on your calculator. Know that there is a difference between standard deviation if it's a population and standard deviation if it's a sample. Yes, the population standard deviation will always be a little bit smaller. Okay, and the fact that it is a distance, right? So it's always going to be positive. Okay, it is never negative. Standard deviation is a positive quantity. All right, I hope you found this video helpful, and thank you for watching.